Summer and Maria French, they got the best grade over here. They got 9.5, 9.25. And so if you want to study together, make sure that you always want to get in group with those who do well on the assignment or on the test, right? Okay. Secondly, some students did not show me work really well. I mean, you guys put into calculator, for example, the number 6. You guys put into calculator and you guys give me a decimal number. That's what I don't want to see. Okay? I say no calculator because I designed the test so that you don't have to use a calculator. Maybe for the test, we're gonna do on Wednesday. What's your name? Michael Lowry, right? And what's your name?
I turned it.
Okay. So maybe on the first test, you can use that for graph. Yeah, which is what we're gonna do today. But just for checking the graph, because you still have to show me a lot of work, okay? You gotta show me step by step. Other than that, you don't have to use calculator. Well, unless they want you to calculate the inverse of something like 33 degrees, for example, which is you cannot have that is not special angle. Yes, then you can put it into calculator, okay? Number 6, I designed so that you don't have to use calculator. It's always related to each other between 40 degree, 130, 220, and 310. And a lot of students got it, okay, but some are not. Number 7 and 8, I have to say that not a lot of students get it. And you guys, I know that you guys went to the math center and asked someone, and I see that. Okay, which is good. Okay. However, the tutor may show you something that you never learned. So they use some kind of weird formula. And so far, we just been learning some basic one. So for number 7 and 8, you just use the basic formula here. You don't have to use like weird formula which we never learned before. Okay? So when you go to the master, make sure you let them know that okay, this formula I never learned this. I never learned this. Okay, and make sure that they know how to use the other one, the basic one. Okay, you have to tell them. You know what you've been doing. Okay? What topic you already learned. You have to let them know. Okay. So please pay attention to that. Let's see what else. Let me see. Another thing is when you calculate the trigonometry ratio of a very big, large angle, like 3,000 or in this number 2 here, 2,000 something. Make sure you have to give me the picture. Okay, you have to give me the picture so that I know that you understand it, the reference angle. Well, you draw like how many circles, something like that. Okay, and you draw the reference angle at least. Okay, so you gotta give me the picture. Okay, if you just put like cotangent of 2280 degree and you hit calculator, give me the that doesn't work. I didn't give you any credit because that one 5th grade can do it. You know, my little, not my little kid, but I know some relative, they like little kid, they can do it. So don't put it into calculator, okay? We don't have to use calculator here. Okay. Number 5. Number 5, they ask you to calculate B and C of right triangle ABC at A. This is not try and error method. You know, you don't plug in 60 degree there and 30 degree there. You know, I want you to use the logic. I want you to reason to get the answer. So this is not try and error. Okay.
How do we show that reason?
Oh, I mean that you never watched my solution, right?
I haven't yet, yeah.
Okay, so please watch the solution. I had to give you guys the link, and it took me a lot of time doing the solution, doing the video, like 40 minutes. Okay, that's for your own good, so you have to watch. You should, okay, to get better. And don't panic because some students didn't do well in the first assignment. That's fine. We still have more change to make it up. However, you have to remember this. Assignment is very important to account for 20%. It's more than a test. It's more than homework, of course. So you have to, you must do the assignment. Okay, you must do assignment. Another thing, and the last thing I want to say, another thing, the last thing, okay? You guys will show me more work in detail. I mean, you gotta show me work some way somehow so that when I read it, I know that what you guys doing. Some student, I don't know, you guys just scramble something and I didn't get it, anything. You wrote down some part over here and some part over here and just everywhere. There's no organization. Okay, so you gotta show me the work so that make sense and it show me that you're doing math. You show me that you use math. Okay, you just scramble everywhere and I don't get it at all. Or you just put the answer and you try to put the formula and I mean how do you jump from the formula to the answer? I don't get it either. Okay, so I put a lot of comment on your assignment if you go through there and read it. So that you guys know this, you can guys can get better next time. Okay. Okay. So don't panic. This is just the first assignment. You get better each day. Don't worry. All right. Any other question? All right. So we have tests on Wednesday. And it's cover everything up to today. So today we're going to talk about a little bit more about trigonometry function. And the test, you can use scratch paper. However, I decided so that for each problem I have space in between so that you can put your work over there. Okay? Don't put your work on the side. You can use scratch paper, for calculation or whatever. But the whole work must be in there. Okay. Try to spend some time so that you can write the whole work in that space. Okay, I have each question in the space and question in the space for you too. And even for the graphing, I create the coordinate system already. Okay, all you have to put is the increment on that system. You guys don't have to draw the coordinate system. All right. In order to do well the test again, just you have to go through the lecture note. You must. You should. Okay? You go through the lecture note. Make sure you understand the whole work. You don't understand anything, let me know. Assignment is kind of help. It's helping also, yes. Go through that at least one time. But the test kind of based on it's kind of similar to the example. So if you go through the example, I'm sure that you guys could do it. Mario? So I have Tyler here. I have Larson. Okay. I have Preston. Jonathan. Okay. All right. Any other questions? Alright, so I want to ask you before jumping into the lecture, how many of you had college algebra last semester? Good, good. So we like only 4, right? So the rest of you guys have college algebra? 2 semesters ago? 2 semesters ago.
More.
How many?
More.
More?
Yeah. 5 years ago. Yeah.
5 years ago. Over here?
No.
It's somewhere else. Okay. So probably some concept you might forget, right? All right. Anyone can tell me how many functions we learn in college algebra? Well, okay, you guys can list me one of them, right? What kind of function we learn in college algebra course? No, I'm not talking about trigonometry. I'm talking about just regular function. What kind of function you already learned in college algebra?
The basic function.
The basic function. Can you list me some basic functions?
X squared.
X squared. That's what I call. What's the name of that function?
It's exponential function.
Okay, exponential function, but x squared is not. But yeah, exponential is one of the basic function we learn in college algebra too. Yes, yeah. X squared function is the basic function of quadratic function. Okay, quadratic function. And of course, we other than that, we also learn linear function, right? We learn polynomial function. We learn a crazy function, and I'm sure that most of students hate it, a logarithm function. Okay. And we also learn a rational function. Okay. Anyone knows what function is? Remember? What is function? Yes.
It's like an equation as a graph that passes the horizontal line test.
Okay. Kind of close, except for the last part.
Vertical.
Vertical line test, yeah. But that is his definition, his old definition. So, function actually is a relation between two quantities. That's the first time when you learn a function. Your teacher, your instructor give you the definition. That's the true definition, a mathematical definition of function. It's a relation between two quantities. And the first quantity we call a domain, and the second quantity we call a range. And those two quantities related some way, somehow, following a certain pattern. And that pattern, that relation, we call the function. And again, it must pass the vertical line test. So in this course, we're gonna learn, we're gonna study more about six more function. We call it trigonometry function. I've been using that terminology for the past 2-3 weeks, all right? So those trigonometry function is based on trigonometry ratio, okay? And because it's a function, so trigonometry function also satisfy vertical line test. Okay, so let's put the topic today. Let's talk about trigonometry function. Today we're going to go through only two trigonometry functions. The first function, we call it the sine function. And the second one, we call it the cosine function, and we also investigate the domain range. We also want to see its transformation concept we already learned in college algebra also. Okay. We also want to talk about the increasing and decreasing interval of the sine function. And the last one, we also talk about if the function is even or odd. Okay? So, I want to write down the standard form, the general form of sine function first. So the function always starts with fx equal, right? Because this is the notation of any function. So fx equal a sine bx plus c plus k. So this is the general form of the sine function. Okay. So in this case, in this function, a, b, c, and k is just a number. Could be any kind of number, fractional, positive, negative. Could be decimal too, if you want to. Okay. And A, we call that the amplitude. Okay, A is amplitude. And it's always positive. Always positive. I'm talking about the magnitude of A. Okay, the magnitude of A is always positive. Okay. Of course, in the real one, we have like something like over here A could be like -3, but I'm talking the magnitude of A is always positive. Okay. The B here, we can use B here to find another quantity, another number, another constant we call the period. Okay, so you see that we're dealing with another terminology here. So we need to understand what means by period. What is period? Okay. Well, you're gonna see this terminology a lot in physics when you have in physics 1 or 2. Okay, they use the word period in electric current. Okay, if you do in engineering, you have to take that course. So period, physically, it is amount of time to finish one cycle of motion. Wow. Just go ahead and write out the definition first. Then I'm going to explain what it means. Okay. So this is amount of time. It is amount of time. Let me see. Let me write here. Okay. To complete one cycle of motion. Okay, physically, that is the definition of period in terms of physics. So in physics, when they ask you to find the period, it means they ask you to find the amount of time, okay, to finish one circle, one revolution, one cycle. But in mathematics, okay, what does it mean? In mathematics, period is the interval on the x-axis. Interval starting from interval starting from origin. Okay. Starting from origin on the x-axis. Okay. At where one cycle of motion can be displayed on the graph. So what does it mean by one cycle? I don't know if you, yes?
What's that word after from? Just
From origin.
okay, thank you.
Okay. So that's the interval from the origin to a certain point on the x-axis. Okay. Where one cycle of the graph can be displayed. Okay. If you have a chance to, you go to the hospital, right? And you see the cardiogram. And it shows you how your heart's beating, right? It's like something like that. So that one cycle is represent on the graph something like this. Then you go back to this. So this is mean one cycle. one cycle of the graph. Okay. Well, of course, in real life, there's a lot of motion. There's a lot of motion. We can use the sine function to describe. Okay. A cardiogram. Your heart beating is one of the example of the trigonometry function. And you see the difference between trigonometry function and regular function you learn in college algebra is that in trigonometry function, it's repeated. So each cycle is repeated. And it's repeated by period. So I call this as one period right here. Okay, I can say that's period. So that's the only difference. It's repetitive, okay, by period. Okay. Okay, example. Let's see we can go through the example. For example, I have a function that look like this. Let me see. Well, before doing the example, I want to talk more about bx plus c. So A we call the amplitude, and it's always positive. And if absolute of A is greater than 1, so we know that the graph is different. Okay. It means it's elongated. You know, when you learn transformation concept in algebra 2, that's what it means. If it's greater than 1, it's elongated along the vertical line, along the y-axis. Okay? And if it's less than 1, okay, it's lessive, or sometimes we say it's open wider, horizontally. The argument inside the parenthesis here, okay, is used to calculate something called phase shift. And the phase shifts tell you that the trigonometry function is transformed or is moved to the right or moved to the left. Okay? So if I set the argument here bx plus c equals 0, and I solve for x, okay, so I get x equal to negative c over b, okay, and if x is positive, after I calculate negative c over b, and if x is positive, I know that the function is moved to the right. Move to the right, how many units? Move it to the right, negative c over b unit. Okay. Remember, we learned transformation concept when we say f of x minus c, and in order to know how many units it moved to the right, we let x minus c equal 0, and we solve for the x. You know, that's why I say how many of you took in algebra 2? How long ago? It's very important because probably you remember something, you still recall some concept, but that's okay. That's okay if you forgot. I mean, now we can review it. So if x less than 0, for example, your x turned out to be negative pi, then I know that the function is moved to the left. Negative c over b unit. All right. How about k? What does it mean? What the k value tell us? What do we know about the k value? Yes.
Up or down?
Up and down. Yes, remember back in the day we learned like fx plus c, then it's moving up, c unit. X minus c move down, c unit. So the k value, let's say vertical or up or down. So I just say k value vertical transformation. So if k is negative, we go down. Right? So if k is less than 0, it's going down. We transform down. So and if k is greater than 0, it's going up, right? It's going up. Alright, so now we can talk about one of the examples. As though you already know, you understand what A means, B and C mean, and K means. We can go through the example. For example, I have something like this. And I say this is trigonometry function. And this, I try to find an example that is in this general form. It means that A, B, and C, and K is the value. Okay? I'm not using 0 for any A, B, C, and K. So, for example, I have like this. I have f of x equal to, let's see, I can have some beautiful one over here. Okay, something like this. 2 sine 4x plus pi minus 1. And I said that this function I have on the whiteboard right now is the trigonometry function because it's in this general form of sine function. So in this case, your amplitude is 2. Okay. B is 4. Pi is the c value. Okay. And k is negative 1. Okay. So from B, we can find the period of that function. We can find the period of that function. Well, I should put the formula over here, but I missed it, but that's okay. I'm going to put it over there. Okay. So over here, B is 4. Equal 4. Right? So the period of this function, which is you always have to find, every time I ask you to graph a sine function, period is always 2 pi over b. So I'm going to box this formula. You have to memorize this formula. 2 pi over b. So in this case, it will be 2 pi over 4. It will be pi over 2. So I have period of this function pi over 2. So I know that one revolution, one circle of motion, or you can say one heartbeat, you know, if you want to say that, can be displayed on the graph with this interval from 0 to pi over 2. That's why I say from origin. Okay, so between 0 interval, I can write over here 0 and pi over 2. Okay, one cycle can be displayed on the graph. Okay. One cycle can be displayed on the graph. And if you do 2 cycles, then it will be another pi over 2, right? So a pi over 2 and another pi over 2 give you pi, right? Okay, that's just for another cycle. Okay, and so on. If you do 3 cycles, then it will be another pi over 2, another pi over 2, another pi over 2. So it will be pi plus pi over 2 because pi over 2 plus pi over 2 is pi. Then you add another pi over 2, give you 3 pi over 2. So if you do 3 cycles, okay, we're gonna learn how to graph this. Don't worry, you will see. You will understand more about this. Okay. Then B and C value. When you solve for x, you can you may know like how much the function is transformed to the right or to the left. Okay. So let's see. I can solve for the something. Oh, this one. I'm sorry. This is called a facet. There's a terminology for that too. So I can solve for the facet by setting bx plus c, which is 4x plus pi equals 0. X plus pi. Okay, so if I set a 4x plus pi equal to 0, then I have what? X equal to negative pi over 4. X equal to negative pi over 4. It means what? It means that when x is less than 0, I know it's moving to the left. And it's moving to the left pi over 4 unit. Okay? So it means moving to the left pi over 4 unit. Compared to the original function. We're going to talk about original function soon. Okay. So what is the k value in this one? Anyone? Negative 1. K equal negative 1. K equal negative 1. Less than 0. And if it's less than 0, it's moved down, right? Moving down. 1 unit. If it's positive 1, then we're moving up 1 unit. Okay. So we're going to learn how to graph this function, but before learning how to graph this function, we need to study the original function. Sometimes we call it the parents function of the general form of sine function. Okay? So the parents function of the sine function happens when we set a equal 1, and we set b equal to 1, and c and k equals 0. Okay? So let's see. If a and b equal 1, so we finished this already. If a and b equal 1, and c and k equal 0, so if a equal 1, b equal 1, c and k equals 0, then fx become what?
Sine of x.
Fx becomes just sine of x. Right? Okay, fx becomes sine. So if fx equal to sine of x only, this function, it is the parents function of any sine function. Why we call the parents function? I don't know if you remember that terminology. X squared. X squared is a parent function of ax squared plus bx plus c. And bx squared plus bx plus c is what? It's just a general form, right, of quadratic equation, of quadratic function. Or another parent function I can give you as example is ax. Ax is a linear function, and this is a parent function of ax plus b. Okay, when b turn out to be 0, then the whole function fx become a of x. Okay, and if a turn out to be 1, then fx equal to x, and that time the line is going through the origin. That is what you already learned in college algebra. Another parent function you might remember is e to the x. E to the x is exponential function. You can say that with e as the base. Okay, or sometimes we call it a to the x. With a is any base. Okay, you want it to be like 2 to the x, 4 to the x. Okay. Okay, so over here, fx equal to sine of x is the parent function. And I want to investigate, I want to study the domain of this parent function. For example, like back in the day, we learned find the domain of quadratic, the parent function of quadratic function, x squared, right? Anybody know the domain of the x squared?
Negative infinity.
Yeah. Go ahead. Yeah.
Oh,
Negative infinity to
positive.
2 positive. That's the domain. I mean every point is defined. Okay. If you plug any value into the x, it turns out to be another value. We can find the output. Okay. That is one of the requirement in definition in function, because in definition of function they say that for a certain input we can find a unique output. Okay. Or anyone remember the domains of 1 over x, rational function, parent function of rational function, 1 over x. Okay. Oh yes.
Negative infinity to 0.
Negative infinity to 0.
And union with
Union with
0 to infinity.
yeah, because we had a vertical asymptote right there. It's never crossed the y-axis. Good. Yeah, huh? That's it. Okay, let's see how we find the domain of this one. Okay. And we want to study the range of this two, and we want to see if this function is even or odd function, and use that concept. We're gonna learn how to graph this parent function, and we use the graph of this parent function to graph this. Okay? Alright, let's see. So the domain of this function is also from negative infinity to positive infinity. Okay. Sometimes I just put r as a real number. Okay. And the range of this function graphically, what does it mean by range?
The y.
The vertical line, okay. It means that the range is to tell you the largest interval between the highest point and the lowest point. Okay? So the highest point and lowest point for the sine function is negative 1 and 1. Between negative 1 and 1. Last time we also talked about this already. Remember when I draw the unit circle, and I say vertical axis is the sine axis, the y-axis is the sine axis, and the sine axis is between negative 1 and 1, okay, of the circle, you know, like this. I have the unit circle like this, and this is sine function, okay, sine theta, and right here, negative 1 down here, and 1 here, so that's the range of the sine function. This information you have to memorize. Another thing is, I know the sine function is an odd function. It's an odd function. And because this is an odd function, so I know the sine of negative theta equal to negative sine theta. Yes. Okay. What else do we know about this? Okay, we know it's odd, we know the domain range already. The period. Period. If we apply that formula, period equal to 2 pi over b. Okay. So what is the b value here?
1.
1. So the period will be 2 pi. It means that I can displace one revolution, one cycle of motion graphically in the interval between 0 and 2 pi. Okay? That's a period. And with this period, I can graph the sine function. And with, from the graph of the sine function, we know where this function is increasing, where it's decreasing, and so on. Okay? Let's see how we're going to graph this. Okay, so I have just draw the coordinate system like this. Okay, and because the period is 2 pi, this is the origin. I can mark anywhere. It's 2 pi over here. Yeah, you can put 2 pi over here. It doesn't matter. Okay. But on the test, make sure that you have enough space for that. Because what if I ask you to draw to graph like a 5 cycle, or maybe something like 6 periods, something like that. Okay, and if you have 2 pi is too large, right? 1 period is too large. This is 1 period. Okay. Okay. If you have 1 period is too large, then if I want you to draw 5 periods, then will be you don't have enough space. So make sure that you have to see that if you have enough space for 1 period, or the amount of periods I want you to graph on. Okay. So this is 1 period, okay, and then 1 period is 2 pi because we already calculated the amount. Okay. So half of 2 pi is pi. Half of 2 pi is pi. And half of pi is pi over 2. Okay, so I divide this period into 4 parts, and half of this is 3 pi over 2, right? Because pi plus pi over 2. Okay. What is the amplitude of this function?
1.
1. Because amplitude is what? Amplitude is actually the value in front of this. Right? So amplitude is 1. So I can find the maximum is 1, and the minimum point is also 1. So down here is -1. It shows me that the graph is between -1 and 1 only. It cannot go beyond 1 or go beyond -1. Okay? The maximum is 1, and the minimum is also negative. Yes?
So if the amplitude was 2, does that mean the maximum would be 2?
Yes, maximum will be 2. And again, you can mark anywhere 2. It doesn't matter. Okay. Alright, so how are we going to graph this? Right. We're going to use a very traditional method. We set up the table. Then later, when you get used to it, you don't have to anymore. Alright, let's see. I'm going to set up the table. Okay. So with 4, 1, 2, 3, 4 value here. So this is x and this is fx. And with x is pi over 2. is pi, 3 pi over 2, and 2 pi. So that's considered as input of the function. Okay, so if x equal to pi over 2, you plug into this function here, sine of pi over 2 give you, well, sine of 90, I mean, yeah. But I'm talking about, I'm asking you the value of sine of pi over 2. What is sine of pi over 2? What's that? 45 is the argument. Sine of pi over 2 is 90 degrees. So I can say sine of 90 degrees or sine of pi over 2. What's that? 1. Sine of pi over 2 is 1. You guys have to memorize the formula. The table. Okay, all you have to memorize the unit cell. There's no other option. All that information, because this pi over 2 is special angle. Okay, you have to memorize. Sine of pi. 0. It's special over here, special angle. You guys have to memorize it. That's why I mean on the assignment I see that a lot of decimal numbers. For example, sine of 45 degrees, sine of pi over 4. Pi over 4 is 45 degrees. And instead of writing square root of 2 over 2, you guys give me a decimal number. Don't write decimal number, okay? Well, at least if it's not a special angle, for example, like sine of 32, 32 is not a special angle. Okay, which is not inside the table I provided you, then you give me a decimal number. Okay, if it is inside the table, if the angle, the special angle, and it's inside the table, I give you, you guys have to memorize. How about sine of 3 pi over 2? -1. Negative because it's down here, right down here. Because it's a sine function here, right? It's pi over 2 here, it's 1. Pi over 2 here. Pi here is -1 here. Okay? And over here, 3 pi over 2 is 1, -1. Oh, sorry, pi is 0, I'm sorry. How about 2 pi? Sine of 2 pi? 0. No other option, guys. No other option. You have to memorize this unit circle or memorize the table. Okay? Either way. Okay? Alright, with this information here, I can graph it. So pi over 2 could be 1 right down here, right? How about, miss 0. How about sine of 0? Sine of 0 is
1.
0. Sine of 0 is 0. Look at the table, it's inside there. Okay, sine of 0 is 0. So I know if it's 0, the output is 0. So the first one right here. If it's pi over 2, let me see.
You gotta move it back a point.
I gotta move it back a little bit. Yeah, right here. If pi over 2 give you 1, okay. Okay, if pi is 0, so down here, I have 3 points already. 3 pi over 2 is -1 down here. Okay. 2 pi is 0 up here. Now I can connect all the points and get a curve. Hey. So this curve represents one cycle of motion. Or you can say one cycle of the heartbeat. Well, of course, you know, this is the periodic function also, but I mean, it's not sine, right? Because it's not, it doesn't have that kind of curve. So it's not the sine function. Okay. So and you see that we use a lot of periodic term here. That's why sometimes we call a trigonometry function or trigonometry function. We call it a periodic function. Periodic function because we're using period to graph function. Okay. So this picture, this graph is so important that you have to memorize the whole graph. If you don't memorize the whole graph, you cannot graph this. Okay, and on the test, I give you 2 questions graphing this. Okay, later on I'm going to give you the third assignment. Okay, on that assignment, I want you to graph only. So that's a good chance for you to practice before the test. Okay, finish the assignment number 3 and learn how to graph trigonometry function, sine function. Alright, let's get back to that function. How we're going to use the function here, the graph of the basic function here to graph that one. So you see over here that this function is increasing from 0 to pi over 2, right? It's increasing from 0 to pi. Then it starts decreasing. Then it starts decreasing to between pi over 2 and 3 pi over 2. Then from 3 pi over 2 to 2 pi, it's going backward, going up one more time. So this is going down. Okay. And it keeps going because this is one period only. So it's because the sine function, the domain is negative infinity to positive infinity. So if I want you to draw 2 periods, then you have to keep going, and it's keep going like that forever. Okay. So it depends on the test how many periods I want you to graph. Okay. If I say I want you to graph between negative 6 pi and 4 pi. So you have to go from somewhere over here, negative 6 pi. So this is 2 pi, right? And now negative 2 pi, negative 4 pi, negative 6 pi to 4 pi. Then you stop over here because this is 2 pi, double that is 4 pi. So it depends on how I want you to graph the function. Okay? How much I want, how many periods I want. Okay? All right. Let's see, we can use this basic function, parents function here to graph that one. Okay. See. First of all, so I'm going to graph the other one. Okay. I know it's transformation already. I know that's going to the moving left pi over 4 unit, move down 1 unit. I know the amplitude is 2. So I'm going to mark amplitude over here first. 2. It doesn't matter. Put over here 2. 1 increment here represents 2. Okay. So in order to graph this function, we have to graph the basic function or the parent function of the period with period pi over 2. Okay, with period pi over 2. We always start with that period. So the first step, when you want to graph, you have to find a p. You have to find period. Okay, and over here we already got a p. The pi is pi over 2. The period is pi over 2. So I say pi over 2 from here to here. From 0 to this point. And I say this is 1 period. And I'm going to grab the sine function, the basic one first, the basic one that looks like this. So I'm going to divide this. After you had a period already, you divide a period into half. So pi over 2 divided by 2 give you what?
4.
Pi over 4. And I keep dividing by half. So this is pi over 8. How about the value here?
Pi over 4.
9 pi over 4?
5.
5 pi over 4? Okay, because how we get a 5 pi over 4? We're gonna add pi over 4 to pi over 8. Right? Is that what you're doing? Or you do something else? What do you do? So in order to get the value here, you see that in order to get the value 3 pi over 2 here, you take pi plus pi over 2. 3 pi over 2. Then in order to get the value here, okay, so pi over 8 plus pi over 4. Just imagine, in order to get the whole piece, right? You get this piece, add to the little piece here, and the little piece here equals to this. Okay, so in order to get the whole piece here, you take from here to here, you add to this one, and this one is pi over 8. Okay, so pi over 4 plus pi over 8.
3 pi over 8.
3 pi over 8? Yeah. So that is the second step. Okay. So after you locate the period, okay, you have to divide the period into 4 parts. Okay, and you label them. That's the second step. All right. Then we're gonna grab the basic function. Okay, we're gonna grab the basic function. So of sine. So sine always start with 0. Okay, we always start with 0, and we move up to the highest point. So I go down like this. Oops. Like that. And this is going down like this. And going down. There you go. So we just finished the basic function with period pi over 2. So this one is the function f of x equal to 2 sine 4x. But we need that. We need to add pi and we need to subtract by 1. Okay. So after we grab the basic function already, that's I want you to grab all the text, okay? We're going to apply transformation. So 4x plus pi over here tell you that, where's my phase shift? Right here. We already calculated the phase shift right here. Right. It tell you that it's moved to the left pi over 4 unit. So you're going to set 4x plus pi equal to 0. And you solve for x, and notice move to the left pi over 4 unit. So with everything, I'm going to move to the left pi over 4 unit. So pi over 4 from here to here, right? Pi over 4 from here to here. So I'm going to move this point over here. You can move it to the left, sorry, so I should do like this. Okay, pi over 4, 0 become this. Pi over 4 becomes 0. Pi over 2 becomes pi over 4. So I shift the whole graph, the basic function of this function, to the left pi over 4 unit. And pi over 4 unit is that much. So this is negative pi over 4. So I'm going to move, okay? I'm going to move. Let me use a different color here. Okay, so I move this point over here, so I'm going to this become like that. Okay, and this I move over here, so it becomes like this. There you go. So this function is fx equal to 2 sine 4x plus pi. Then we also finally we have to take -1 into consideration, and -1 tells us if it is moving up or down. And in this case, we're moving down because it's -1. Okay, so I'm gonna move the whole green function here down 1 unit. Use another color. So I'm going to move down 1 unit. So 2 here, so 1 over here. Right. It's -1 here. So the maximum point, okay, the maximum point right here, right? It go down 1 unit. This is also go down 1 unit. Everything go down 1 unit. So this go down 1 unit here. And this go down here. And I'm gonna have a graph that look like this. Okay. There you go.
Bless you.
Okay. And that is my final function. So f of x equal to 2 sine for x plus pi minus 1. So if I ask you to graph 1 period, this is what you have to do. Okay? However, if I ask you 2 periods, then you have to keep extending. You have to extend it until you have 2 periods. For example, I want you to graph from pi, negative pi, let's see, negative pi over 2, 2 pi over 2, for example. So this is negative pi over 4, so negative pi over 2 over here, right? Negative pi over 2 over here. I want you to graph from negative pi over 2 to pi over 2. What if I want you to do that? So you see that we missed some part over here. Because over here we stop at negative pi over 4 only. So we have to extend it. So okay, so I'm going to extend it so that I hit negative pi over 4. So it's over here. So it's going to be something like that. There you go. And I have to extend it to the right because I have it until pi over 2 and pi over 2 over here. And if we stop over at this point, pi over 4, then it's not good, but we have to keep going. So it's going to keep going up. So it's going to be like this. Okay. So it depends on how many periods. It depends on the interval I want you to graph. Okay? If I say 1 period, it will be easy, of course, right? But if I say like between negative pi over 2 and pi over 2, make sure you have to extend it. Okay? Any question? So what you have to do when you graph sine function, periodic function, you have to use the basic function. Okay? Any question? Alright, so that is the first one I want to talk about today. The second function I want to talk about, it is the cosine function. And it's kind of similar to the sine function. It also has the form f of x equal to a cosine bx plus c plus k. And everything in any other concept is the same. They also have period. Okay, we have using that formula p equal to pi over b. Okay. They also have phase shift is negative c over b. Okay. So phase shift is negative c over b. They also have a k representing it's moving up or down. Okay, so I don't want you to write it again. And if I set a equal to a and b equal to 1, c and k equal to 0, Oh, you guys still on that side? If I set a equal 1, c and k equal to 0, then my general form becomes f of x equal to cosine of x. And this is my parents function of cosine. And we're going to use that parent function to graph any cosine function. To graph any cosine function. And parents, because parents function of a general form cosine function is cosine of x only, and the period, we do the same period is 2 pi over b. B is equal 1, so the period are only 2 pi. Okay, it's the same thing. Okay. The period will be 2 pi. Alright, let's see if we can graph that. We grab the parents function of cosine. So we're gonna set, we're gonna use the table, x here and fx here. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So on the test, you guys show me all the steps like that. Okay, you guys don't put into calculator and get the graph, and you know, it doesn't work that way. Okay, you must understand it. Alright, let's calculate the output here. If x equal to 0, cosine of 0, you plug 0 here, f of 0, cosine of 0. Cosine of 0 degree give you
1.
1. You got a unit circle. So cosine over here. 0 degree is 1. Cosine of pi over 2, 0. Oh, okay. Cosine of pi, negative 1. Very good. 3 pi over 2, 0. 2 pi, 1. Good. So all of this information here I can use to graph this. So the period is 2 pi. Okay. So I just mark 2 pi there. Amplitude is 1. So 1 here, and negative 1 here. Okay, so after I got the period, I divide it into 4 parts. So this pi over 2. This pi is 3 pi over 2. So when x equal to 0, fx equal to 1. So when x equal to 0, fx equal to 1. So this is the first point. When x equal to pi over 2, fx equal to 0, this is the second point. When x equal pi, fx equal to negative 1, this is the third point. And so on, you have all the points. So you're going to have something like that. Okay. So you see that the shape kind of look like this. You know, but it looked like the sine function moved to the left pi over 8 unit. It looked like the sine function that will move it to the left pi over 2 unit. So if you just imagine you move the whole piece here, pi over 2 unit, then it give you that. So remember, you have to memorize this. Cosine of x. Let's see if we can graph something more complicated using the basic function of sine. Of cosine. Let's see. How about this? Very interesting one right here. What is this? I want you to graph f of x equal to 20 cosine pi x minus pi over 2 plus 10. So the first step, we have to find period. Period is 2 pi over b. What is the b value here? Pi. B value right here, right? B value right here, in front of the x. So it will be 2 pi over pi, 2. It means that one revolution, one cycle of motion can be represented between 0 and 2. Okay. I know amplitude, 20. So now I can graph. Hopefully I have enough space for the whole thing because the amplitude is kind of big, right? 20. But that's okay. I mean, I can mark any point on the vertical axis. That's it. So I have period is 2. So and let me see on the question. Let's see how much interval I want you to grab. So I want to grab between -1 and 3. And one period is 2. So let's see 2 over here. See 2 over here. Okay. So after you got a period, you divide period into 4 parts. 2, so half of them will be 1, half of them will be half, and over here will be 3 over 2. Okay. And I say the amplitude is 20, so I say over here 20. It doesn't have to be the same increment with the x. Okay. And I say down here is -20. Alright, let's grab the basic function in that period. Let's grab the basic function in that period. So this is the cosine function. The cosine function always starts at the amplitude. So we start at 20.
So you're not considering the 10, the up or down, the k number?
Oh, we will! Later.
Okay.
Oh,
So
first,
yeah. So
later, after we this, we're going to transform down. Okay? But always start with the basic one first. Okay? So I'm going to move down here. So cosine function that look like this. Alright. It's going to be like this. There you go.
I have a question.
Yes.
How do you get the -1, the -1?
Oh, this one? It's just a part of the question. It's a part of the question. Yeah, it's a part of the
Okay,
question.
okay.
This is I want you to grab between -1 and 3. That's what.
Oh,
Yeah. Oh, this the answer right here. Answer starting from here. Okay, everybody understand the basic one? Okay. So after I start the basic one, we need to see how much is go down, how much is moved to the left or right using the phase shift. So we have to calculate the phase shift. Okay. Phase shift is pi x minus pi over 2 equals 0. Let's bear with me for a couple more minutes, okay? So I have x is equal to 1/2, right? Yeah. It means that we move to the left or right. Left or right. We have to move it to the right. Moving right. 1/2 unit. So I'm going to move it to the right 1/2 unit, okay? Look. So everything move. This is 1/2. This increment right here. So I move this one up here, over here, this one down here, this one over here, this one over here. So my function becomes like this. Alright. I already moved 1/2 unit to the right. And how many we need to move down?
We go up 10.
Go up 10, very good. Up 10 because it's positive, okay? We're not moving down. If it's more negative, then we move down. So move up 10 unit. 20 is right here, 10 is half. Move up 10. We're gonna move the red one, okay? Not the purple one, okay? So red one up 10 units. So over here, move up 10 units, so it become 30, right? So we're gonna have something like this. So everything up here, here, here. So we're gonna have something like that. There you go. So the value here will be 2.5. Will be 2.5 is 5/2. But we want between what? We want it between -1 and 3. So we have to extend it. So this is 1, 2, 3 as another piece. 3 right here. It says 1, -1 over here. So we have to keep extended until we get to -1 and 3. Okay, so what will it become? So we're gonna have here, right? Then we're going down to this one. Okay. So we're gonna have something like this. Okay. Mine is not really good. Then this is going down to this. I think I got something wrong. We gotta stop right here, sorry. So it's like this. There you go. And this one over here. There you go. Okay. So then remember that you always have to use the basic function to graph. Then to graph for one period first. Then you start shifting. Okay? By look at the phase shift, by look at the k value. Okay? Usually you have to do like pre-graph like this. Then you label them. So this is your final graph. So this is you label. This is 20 cosine pi x minus pi/2 plus 10. Okay? Any other question? Okay, I think that's all for today, guys. So you guys have to practice. Hold on. I just found one thing for you. I'm sorry. This is the assignment number 3. There you go. It's not due until you a week later, a week after the test though. But it's good if you go ahead and practice them, because this is about graphing. What's that?
Next Wednesday, written test.
I believe so. Yes.
I have a question about
I think we have to do something else.
Yeah, something I don't want to do. But
You see, I need 3.75.